Alright, so before we start talking about the other methods of solving, we're going to take a moment and talk about the types of solutions that we have. So now that we know what it means to solve by graphing. So when we're thinking about the graphs of our systems of equations and of linear equations, we can have one of three types of solutions. We can have one solution where they intersect. We can have no solution where our lines are parallel to each other. Or I would have infinitely many solutions because we would have this line, and then right on top of it, we would graph our second line. Now, each of those has its own term, so its own vocab term. So if we have a one solution answer, or really if we kind of go back, if we have an answer, we call that system consistent. Okay, so if we can find an answer, it's consistent. If we have one answer, it's independent. Spelled independent wrong. Okay, it's independent. If we have infinitely many solutions, that's dependent. And if there's no solution, then we call that inconsistent. So again, if there's an answer, it is consistent. If there isn't an answer, it is inconsistent. If we have one answer, it is independent. If we have infinitely many answers, it is dependent. So now we're just going to practice classifying our systems without actually having to graph them. So if we are trying to kind of decide how to figure out what these are, what the graphs are going to look like, without graphing, there's some things that we want to look for. So if it is parallel, that means that our slopes have to be the same. Okay, so for this one in the equation, we're looking for the same slope. And our y-intercepts have to be different. Now, if they have the same slope and the same y-intercept, the equations are going to be exactly the same. So that's going to give us this one. So this is the exact same equation. And then for them to intersect, the slopes have to be different. Now it's not that they have to be one positive, one negative, they just have to be different. So if an equation has a slope of 3 and a slope of 2, at some point they're going to intersect because they're not parallel. So remember, equations are either parallel where they don't intersect, or if they're not parallel, then they have to intersect. And they will either intersect at one point, or we're going to have the same equation, so they intersect at every point. So that means when we're classifying, our first thing that we need to do is solve each equation for y. So for this top equation, if we solve for y, we would add the 3x over. So we'd have y equals 3x plus 4. And then for the second one, if we are solving that, we would start by subtracting the x. So we'd have negative 1/3 y equals negative x plus 1. And then to get y by itself, we'd have to multiply everything by a negative 3. So that would give us positive y equals positive 3x minus 3. So these are the equations that we are comparing. So when I'm looking at that, these have the same slope with a different y-intercept. So that means that these are parallel lines. So we would call this one inconsistent. Okay, which means that it's a no solution one. Okay, so we're going to do the same thing with this next one. So again, we're going to solve that equation for y. So for that top one, the first thing that we're going to do is subtract the 2x. So 3y equals negative 2x plus 1. Divide everything by 3. So y equals negative 2/3 x plus 1/3. And if we solve the bottom one, that one we just have to subtract the 4 over. So we would have y equals negative 4x minus 3. So again, this is the system that we want to look at, so we're comparing the slopes. So here we have different slopes, so that means at some point they have to intersect. So since we have an answer, it's consistent. And since these aren't the same, we're going to have one answer, so that is independent. Okay, so one solution. All right, last one, if I'm looking at it, the top equation is already solved for us. So I'm just going to rewrite that. And then that bottom equation, again, we are trying to get y by itself, so we're going to start by subtracting the 6x. So negative 3y equals negative 6x plus 9, and divide everything by negative 3. So that's going to give us y equals positive 2x minus 3. So again, when we're comparing those equations, they're exactly the same. So since they're exactly the same, when I graph them, we graph a line on top of itself. So we're going to have an answer, so consistent. And since we're going to have infinitely many answers, that means that the system is considered dependent. So that's, again, infinitely many answers.